Professor Tej.
Hi, Uma. Good
Hi.
morning.
Good morning. Good morning. Shall we start now?
Yes, ma'am, I'm ready.
Okay. 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 Thank you.
So good morning, Tej sir.
Good morning, sir.
Karpagalakshmi ma'am.
Yes, ma'am.
Okay, ma'am. We'll start now, ma'am.
Yeah, okay. Very good morning to all. It's my pleasure in welcoming you all to the second day of 5-day online ATAL FDP on AR and VR. That's happening in Department of CSE, Naramani College of Technology. Now, the session 5 of machine learning and its applications in augmented reality and virtual reality. I feel so proud that we have Dr. Tejbanta S.Chingtham, Professor CSE, Sikkim Manipal Institute of Technology, Sikkim, as the resource person for our gathering. Let me take privilege of sharing the information about the resource person of today's session. Dr. Tejbanta is a professor in computer science and engineering at Sikkim Manipal Institute of Technology and also currently the CEO of AICMUC SMUTBI, which is a technology business incubator of Government of India. He has more than 2 decades of experience in various domains. His expertise are in the field of artificial intelligence, mobile and autonomous robots, machine learning, and human-computer interaction. He is an alumni of Indian Institute of Technology, Guwahati. He has published more than 160 papers and articles in various journals and conference proceedings in both national and international journals, including an article in Forbes. He also holds patent in human-computer interface. He received grant for 2 research projects. He has also been an expert member of the Tata Empowerment Fund under Tata Trust. He has been responsible for building the startup ecosystem within the university and has extensively worked towards upfillment of entrepreneurship through entire northeastern regions of India. He regularly publishes such as in Forbes India and also in journals and conferences, including some published by IEEE and Springer, etc. He also holds a patent in field of AI HCI. He is currently on mentor board of 16 startups working in various domains such as e-mobility, agri-tech based on AI and ML, etc. We hope the great session ahead. Let me hand over the session to respected resource person of today. Session over to you, sir. Welcome once again, sir.
Thank you so very much, Ravi Verma, ma'am. Thank you so very much, everyone, for taking this time. A very, very good morning to everyone present here. I would like to share my slide. Is this okay to share now?
Yes, yes.
Okay. Please let me know if it is visible.
Yes, it's visible.
Thank you so very much, and very good morning to everyone, and really humbled with the warm introduction and the welcome. And at the outset, I would also like to thank the Institute as well as the Department of Computer Science for giving me this privilege to speak to you today. Professor Uma has been very, very kind to extend this invitation to me. I hope that everyone is safe and fine. I'll just take you through a brief because we have just about an hour, and I think we may not be able to have the opportunity to deep dive at every level. But as an overall preview of what we can do in the machine learning domain and what are the applications that is available as of now and how we should actually approach as an outline, I will take it forward. And in case there's anything that I can support or you would like to work together with me, I'll be more than happy to collaborate collaborate and learn together. So whatever little learnings that I've had so far, because you all come from various domains and you all are expert in various domains, whatever little learnings that I've had in this years of my research, I would like to share with you. And probably from here, we can take things forward. So with this, I'd like to begin the first thing first. I just want to tell you about machine learning. The word machine learning was coined sometime in 1959 by Arthur Samuel of IBM. Though the word machine learning was coined in 1959, a lot of work has already been in progress, except that the name has come later. A lot of work has been done before. And it's important for us to also briefly define, because putting it across, I do not want to deviate from it, so I'm just reading out from the slide for this particular definition. Machine learning is the study of computer algorithm that improves automatic experience and by use of data. Or in other simpler word, machine learning is a typical or a type of artificial intelligence that allows software applications to become more accurate without being programmed to do so. So machine learning algorithm uses historical data as an input to predict new outcome. When I look at this, I can tell you one thing: machine learning is nothing but a prediction software. So the base idea that we have to remember is, at the end of using machine learning, the outcome of all machine learning products that we all work should become a predictable outcome. That is, if you are deploying machine learning, at the end, we have a set of all historical data. We have some data in the beginning, and then based on that, we should be able to predict the outcome. Let's say, for example, with the current pandemic and the current lockdown going on, with the kind of information that we receive and keep reading on the newspaper, it seems like the machine learning research that has been going on around the world seems to be quite accurate if you look at it, because it was told that, you know, the second wave in India is going to be very high sometime in May, and then gradually by mid-June it will come down. And if you look at today's map today, if you see the entire ratio, it has gradually declined across the country. So this was what machine learning could predict. And it also predicts that there could be some kind of rise in a third wave later on, and so on and so forth. So we'll have to wait and see whether the machine learnings are, I'm not saying that machine learning predictions are always 100% accurate, but having said that, we could use this data, the data that is available, the historical data that's available, and we should be able to predict. So that's exactly where machine learning should be deployed. Meaning, when you have a system, when should we use machine learning is the first thing that we'll have to understand. Based on this definition, we should figure out whether we are actually, is it really necessary for us to use machine learning? Because today the trend is that everybody wants to talk about blockchain, everybody wants to talk about robotics, everybody wants to talk about artificial intelligence. They put every little thing anywhere, and then they say that this is a machine learning thing. I don't think that should be the accurate way. So as faculty members, as well as research community, what we need to make things very, very clear to people who uses this is that, you know, whenever there is a system that requires some kind of prediction based on an existing data, probably machine learning will be the best option. So that is what we need to do. There are other new things that has come in, but machine learning is one of the new promising area, because this has been experimented for a very long time. So moving forward, what are the applications of machine learning? I'm just putting into a rough space, but this does not really mean that, you know, this is the only domains that's available. But some of the traditional space where machine learning has been deployed includes, you know, automatic language translation, medical science, stock brokering, online fraud detection, email spam and malware filtering, self-driving cars like the one we see in Elon Musk, you know, the one that we see in Tesla, that is being launched. It has continuously been learning over a period of time to drive in traffic. So you have traffic predictions, speech recognition, image reconstructions or recognition, and so on. These are some of the things that has been constantly been deployed using machine learning, and we see that a lot of good outcomes are being predicted. For instance, if you talk about the medical imagery, you look at CT scans, and we look at X-rays, and we are able to predict some kind of future, you know, predictions of what are the likely changes that may occur based on the kind of instances or records that has occurred worldwide. So if you map it with some of the images that is already in existence, what will be the next thing that will happen? So these are a few things that has been able to successfully predict. So if you look at and another example is like, for instance, if we know the rainfall, say many of you are here in Tamil Nadu today. I was in Tamil Nadu in Erode sometime about 20 years ago. So when I was there, I could see, we used to wait for the rainy days because it becomes cooler there. And I come from the colder region, so I used to find it very, very nice when it rains, and I used to enjoy that. So I used to look forward. But we didn't understand it was. But if you want to look at it, you could actually predict by understanding the number of days it has. For example, for 5-6 days, it has been constantly windy, and then the season is sometime in May, June, July. Then the chances of rainfall happening becoming more prominent. So these are things that we can record. So last year it happened, 2019 it happened, 2018 it happened, 2017 it happened. So 3-4 years continuously, if there is heavy wind, if there is the sunrise is become late, for example, I'm just assuming, and then the temperature and pressure goes down, for example, then we generally might have rainfall. So that is the kind of thing that has happened for the past 3 years. Then probably if these 3 things happened in 2021, we can predict and assume that rainfall may happen about 80%, 90%. How do we predict it? I'm coming to that. So these are the data that is available for the past 3 years about the rainfall, the data that is available. So what should happen in case something like this happen? What will happen tomorrow? We can generally predict, have an average successful prediction percentage. That is what machine learning is bound to do. So looking at it more closely, any algorithm, generally what happens that I have seen, especially in the academic community, especially with the student community that I see across, not very sure how Professor Uma is going through around your school, around your School of Computer Science, your students, how they're handling it. But what I see here is, any student just use any of this algorithm, any one algorithm in machine learning, and they say, I'm using machine learning. I don't think that really is a correct way of making a complete use of machine learning. So when I talk about machine learning, we should be able to predict the future outcome based on the previous events. So on the basis of this, how do we actually do this? Predict future based on previous events. It's very easy to say a very simple statement saying that, okay, you predict what is going to happen in future based on what has happened earlier. Professor Uma, I'm audible, right? I'm still connected?
Yes, Tej.
Yeah. Please interrupt me in between. I'm just assuming that, I'm continuously speaking, thinking that the network is there. I might be disconnected. So interrupt me if
no problem.
Right.
Okay.
Yeah.
If any problem, I'll inform. Right.
Right. Please. Thank you so much. Yeah.
Thank you.
I would like to tell you there are 3 important components that we have to always remember. Unless these 3 components are incorporated at some point of time or other, probably the system that we are trying to define as machine learning may not actually fit in as a machine learning system. So it could be a component of machine learning, but it will not be a full-fledged machine learning system. So when we talk about a machine learning system, we generally there are only 3 components. Actually, looking at it very clearly, it's like there are just 3 components. One is clustering, classification, and regression. If we have these 3 components in your system, we can proudly say that the entire system is a machine learning system. So what is clustering, what is classification, and what is regression? I'll come to that step by step. But let's remember that whenever we talk about machine learning, there should be at least 3 components if you want to call it a full-fledged machine learning system. But if you're just putting part of it into machine learning, a part of algorithm, because each one of this clustering, classification, and regression has multiple algorithms. I'm going to come to that. But each one of them has got subdivisions and various techniques of solving each one of these problems. So what I'm trying to do is, you have a huge data set comprising of lakhs and lakhs of data, or millions of data, or billions of data, for instance. So based on this, how do we find whether the product that we have, based on this, how do we have a correct, accurate prediction? Let's say, for example, we have seen so many vaccination. If you're talking from the present context, if you want to have a study, what we can do is we can do this clustering of this vaccination. For instance, you collect the data of all the vaccine related information, because in UK, how many people have been given this vaccine, and what is the age group, what is the gender like, and is there any health conditions of the people that is being done? Say, for example, is there somebody who was suffering from cancer and this vaccine is given? How do they react? people with blood pressure, how do they react, all this data if you have, and on the basis of this, if you want to make a prediction, say for example, after all this data is available now, you have a patient coming to you and say that he has got diabetes and he also have some other problems along with, say for example, visual problems, eyesight problems, for example. Now you want to see how effective is this vaccine if you put on him. He hasn't taken the vaccine. So how do you predict it? In that case, based on this data, I am not going to say that 100% whatever I'm going to say is correct for him, but based on all the data that has been available so far worldwide, I'm going to tell Mr. XYZ, for you, these are the chances. It may be 100% successful with this vaccination. Or it may say that with diabetes condition, you may have this problem for the next few days. You may have fever for first day, second day. This kind of information, based on what is studied earlier, we can do some kind of prediction. So the prediction in general, depending on how much of training, how much of learning we do, based on that, the outcome will also differ. But having said that, the outcome, this is what actually a machine learning should do. This is a general overview of what machine learning should do. So therefore, to do this, we require three different things. One is clustering. When we gather this data from across the globe, we are going to bound to have data which is mixed. For instance, I asked one of the teacher asking me, please give me the attendance of the class for today. So he was sending the attendance in an Excel sheet, and instead of, somewhere he was typing something, instead of the attendance alone, he or she sends the marks also, quiz marks for that day, for example. It's mixed. Now I don't know which column is for quiz marks and which one is for attendance. I get confused. So this is a very typical example wherein we as teacher, we come across this very frequently. Now I have to call up Professor Umaiza, ma'am, you send this, ask me to send this, and then I've sent it, you have sent it to me. But one column has got some number, second column also has got some number, but nothing is given, no level has been given. So which one is what? Then she says the first column is attendance, second column is quiz marks. Oh, then I realize, oh, that is what it is. So this is called clustering. Then we go into classification. So the next classification is whether this data that we have got for attendance and what you call the quiz, are they relevant? I want to allow only students who have got 80% attendance to be allowed for the exam. Will this data for quiz marks, will it be useful for me to segregate 80% attendance? No. So that case, what we do is we classify which are the important part of it. So we classify them. If you want to say which is the topper in the class, who will be the best in the class, attendance, if I take attendance record, I will not be able to say, oh, this is the, suppose 100% attendance, I can't say that that's the best student in the class. I can't, it will be wrong, isn't it? So what we need to do is, if you want, you can have a correlation between these two data, but generally what happens, we have seen as teachers, generally who are always present in the class, they also tend to perform better. That correlation can be possible, but by having attendance 100%, it does not mean that he's the best in the class. So this is what we mean by classification. We classify based on what we actually need for this particular study. What are the data that we actually need? So we take them, and the remaining we classify and take them out, filter them out. Okay. After this data is available, we do some mathematical calculation. In fact, I shouldn't call it mathematical calculation. These are more of statistical calculation. So based on this calculation, we do some regression based on this. So we get some kind of, there are two outcomes of this. One is probability, another one in the form of a percentage. Okay. So as a probability, and another in the form of some kind of an integer number, which will be in the form of a percentage. So in both the cases, we will be able to get this by having this free segment done on a set of data available. So I'll just tell you when should we use clustering. When we have so the first thing is clustering, as I was telling you. Once you have a large set of data and you do not know which data is for what, you have mixed level of data for blood pressure also, you have data for temperature also, you have pressure, you have data for what you call sunrise and sunset also, you have data for what you call the oxygen level, SpIO2 level also, all this data mixed together in an Excel sheet. And now you want to figure out which one are the data that we are going to use, which will be needed. So we might need to do some kind of clustering. So based on this clustering, we have different models for doing this clustering. So some of the clustering types are density based. So depending on what type of data it is, whether it is density based or is it a distribution based, centroid based, or a hierarchical based. I'm not going into deeper things of all this because I think we will not be able to have that time constraint, because I'm supposed to complete all this in about an hour's time. So I'll try to summarize this. I'm sure many of you are aware, but and I'm sure you have already used it as well. So what happens is you could use any of these techniques to actually classify them, like how I gave you the example of the Excel sheet, wherein you had this, where you had this case of, the attendance and the quiz marks or the marks that is scored by students in the class. So based on this, what type of data you could have, even in that, by mistake, one of the teacher also recorded, the temperature from somewhere. He measured all the students' temperature when they entered the class. They took the thing that also got recorded there, for example. And now with the temperature also included, we'll be all confused. How should I calculate who all should be eligible for exam? Now, I think the temperature may be important because those who have high temperature may not be allowed to enter the class. So this may be correlated things are there, but just because a person has got temperature in normal range, it's got 78 or 80, for example, or for example some other value for that matter, and if you're trying to correlate with the attendance, probably it may not be correct. If you try to correlate the temperature of a person with the score in the class, then probably again that will also be not correlated. So what are the correlated ones? You please try to bring it. And for that matter, we have various algorithms, some of the very commonly used algorithms. I'm not saying that these are the only algorithm. There are many algorithms. Some of the very, very commonly used, you'll find them frequently used, very, very commonly used is a K-mean clustering algorithm, affinity propagation clustering, DB-scan, the optics, then Gaussian mixture, or for example, the BITS algorithm. These are some of the very, very commonly used. You'll find many papers. You download the papers on machine learning, you'll find that these are the common algorithms that you'll come across. So these are the ways in which we can do the clustering. Once you have identified they are unlevel, you do not know what data means for what, whether you're going to need them. Once you are able to cluster them together into a group, then probably after this, we will go into the next step. The next step is called classification. So when we talk about classification, you have it is a process of recognizing, into grouping them into different subpopulations. Let's say, for example, in a classroom, let's say you are in the classroom, and then you say, for example, from the top of the, say, for example, there's a drone. It takes a picture from the top, say, for example, an aerial view of the classroom. Let's assume that there is no what you call ceiling on the top, and then let's assume that there is a classroom going on, a teacher teaching and a set of students, some 30 students seated in the class, and then a picture is taken. Now, in this, using this, what we want to do is, I want to classify in this classroom which part is for the student and which part is for the teacher. How do we do this? We need to use some classification. We have to subgroup this population. So what we can do is, you will find that the students will generally be seated together in a group. The teacher is separated in between the teacher and a student. There will be some gap, and then there will be some blackboard or some kind of a table or a chair or a kind of a thing. So there, what we do is we put a division there in between where is the largest segregated groups. So we subdivide the entire thing. Though we know that this is a classroom, we wanted to find a picture of the whole map of say, for example, a particular town. We zoom it further and we got into a school. Once we zoom it further, we wanted to see how many students are there and how many teachers are there. Generally, in one class, there will be one teacher. Unless and until the teacher moves about in between the students, you can easily figure out if the teacher is writing something on the blackboard. At that point of time, if we take a photograph, for example, you will know how many teachers are there and how many students are there. You'll be able to segregate between this. So this is what I mean by classification. You segregate them into subgroups, into smaller groups. Let's say, for example, in your attendance, you can divide those attendance into, say, for example, we are giving marks for students who are attending classes. This is something that we practice in our university, in Sikkim Manipal University. What we do is, say, for example, a person has 100% attendance, we give them 5% marks so that we encourage them to come to the class more frequently. So what we do is we give them 5 marks. If you have 100% attendance. So for example, 90 to 100, we give 5 marks. Say, so 80 to 90, we give them 4 marks. Then we keep on reducing up to certain cutoff, where the last cutoff says that, you get 1, and below that, anything below 75, you don't get any marks. That is what we can actually segregate. So what we will do is, we have, though it is the attendance of the class, I've taken the column out of what Professor Uma has given. I've taken out all other attendance, all other marks. I have taken out temperature, I've taken out marks also, quiz mark also I've taken out. Now I finally decided that, how many marks should be given in the class, I've taken out, and then based on only the attendance list, I have subdivided the entire class of 30 students. I have subdivided into 100 to 90 to 100, one group. 81 to 89, another group. Then 71 to 89, another group. So I have divided them into subcategories, and then on the basis of this group, I ask the machine learning to identify them and mark given in this manner. In the next session, what I will do, I'll simply give this Excel sheet to the computer program. It'll take out and give the marks. I don't have to do. A lot of work will be saved for you in the next semester. This time you're giving the training to the computer and saying that, you divide them into groups. Those attendants who I have a data like this, take out only the unlabeled one, cluster it in such a way that only the attendance is taken out. From that attendance, you segregate between 90 to 100, one group, 81 to 89, another group, 71 to 79, another group, and then 61 to 79, another. Likewise, you group them into different things, and then you give the highest mark. You give 5, and then 4 and 3. You classify them, and you design a program like this. Next time, all you have to do is ask for the attendance of all the teachers, put it into the machine. The marks will come out. The marks would be already allotted when you get the final outcome. You will not see attendance. You will not say anything. The computer will give the marks by itself. It's an automated process. So machine learning will be doing this for you. So this is possible. This is the kind of thing. So you have done the clustering. You can do the classification in this manner and subgroup them. So there are various algorithms to do this. Let's say, for example, logistic regression is one of them. Naive biases is one of them. Stochastic gradient descent is one of them. Some of the very, very common ones. This is not the only 7 algorithms. There are, I think more than 50, 60 different algorithms that's available as on today. And as we see, more and more PhD scholars coming out with a slight changes to the existing algorithm, and then they say that this is a new claim. So in terms of innovation, because I deal very frequently with innovation, so there are 2 types of innovation. One is called the disruptive innovation. Another one is called incremental innovation. So in PhDs we find a lot of incremental innovations. I do not say that it is wrong, but it is not life-changing new algorithm. It is an existing algorithm, slight modification to it. That is what a lot of people have written. So you'll find a lot of those algorithms. So if you consider all of them, we'll have more than hundreds of algorithms available for classification. You can take up any of this. You have seen decision tree, random forest, and one of the very, very common, which you'll find in many of the papers, is the SVM, or what you call the support vector machine. So one of the logistic regressions that we could easily use logistic regression is just identifying true or false. Identifying true or false, logistic regression. So we could talk about spam mails. Okay, so I'm sure many of you are aware. Whenever an email comes in, your server, mail server, will basically segregate this into 2 different segments. One is a spam email, and what is the good email known as? Anybody has any answer to this? Anybody can point out what is the good email known as? Anybody can just unmute. I just want to see whether I'm still connected or not. That's why. Anybody would like to try? Emails that are not very good for you, you have put it as spam. The good emails, what do you call it? Am I connected?
Yes.
Okay.
Sir,
anybody would like to answer and say?
Yes, sir.
No, the good emails. I'm talking about the good emails. The good ones where you are, which is important.
So
Yes,
it
anyone?
comes in an inbox. So
Yes, which comes in your inbox. Sorry?
Starred. You mark that mail as a starred mail. If you want to mention it as an important.
Not starred email. I'm not talking about starred mail. It's not important. I'm talking about the one that is allowed inside your email ID. In your inbox, and the one which goes into spam. There are 2 segregations. I'm saying that you design a computer program which, whenever there's an email that comes in, you divide into 2. The other one which is bad emails, that are called spam emails. The good ones which goes into your inbox or your other where you will be checking. What is those email known as?
Ham emails.
No idea. Good, very good. Professor Uma, I think we can give chocolate to this person. Who is this to answer? We should reserve some chocolate for him, sir. Thank you so much, sir, for the answer. It's called ham emails.
Okay.
Because we should have this, it'll be interesting when we have this. So you have spam and ham. Okay, the good emails are called ham mails. So you could actually segregate into a binary decision whether it is good or bad. Okay, if you're talking about email, you can consider it as a ham or a spam. So that is how we just classify. So here we are classifying the subgroup that we have classified is into 2. Only 2. All the emails will come into your mail server. From there, it just divides into 2. From there, if you want to divide multiple things like, promotion, social, so many things you want to put into different inboxes, that's up to you. But the generic thing that if you want to design, this is the way to do it. By using machine learning, you can just classify. I'm just trying to explain how classification is done, right? Thank you so much for the answer, sir. Okay. The next thing that we look at is, regression analysis. So regression analysis, as I was telling you, by the time you do your classification, so I'm just going back, by the time you have your classification, you'll have a rough idea of, a probabilistic idea. Say, for example, you say, if you look at all the database for the entire day of, say, sunshine, the pressure, humidity, the previous year's rainfall, all this you have recorded for the past 3 years, for example, or 5 years, you have the record. So today's data you collected, okay? And you want to predict what will happen today in the evening or tomorrow, what will happen. So you have collected the previous year's record for the last 5-10 years record you have. So on the basis of this data, you check which one is very similar. If you have temperature, say 35 degrees Celsius, a heavy wind, and then their pressure is high or low, for example. So under such circumstances, what happens? Okay, what you do is you check for the previous years and you find a similar situation today. Which one maps the best? And then last year, in the last 5 years, whenever this type of situation happened, it rains in the afternoon, for example. Okay, it rains in the afternoon 50% of the time, or say, for example, 70% of the time, or out of the 10 years of record that you have, 7 times it rained. That means 70% it has rained. So what you do is, if all this data matches with today's data, what you will say is, based on today's data and considering the last 10 years, out of 10 data that I have, 7 times it rained if you have similar situation. So tomorrow what you can do is, you have a probability of 70% rain, chances of rain tomorrow. So that is what I'm trying to tell you. So you'll have a 0.07 probability of rain tomorrow. So that is the kind of probably you'll get a probabilistic idea about what will happen tomorrow, but it may not be still very, very accurate. So if you want to improvise on a number or a digit as to how accurate, a little more accurately, if you want to analyze, what you will do is you will have to have different type of analysis based on the regressions. Different type of regression analysis can be deployed upon the classified cluster groups that you have had, and there are various regression analysis available as well. Like linear regression, logistic regression, ridge regression, lasso, polynomial. These are some of, again, I'm telling you, these are not the only things. These are some of the most very, very common form of analysis that is available for regression. So, so using this kind of analysis, you'll be able to come to a more accurate prediction. The prediction, so at the end of the day, I was talking about machine learning being an art of predicting what will happen in future based on the previous instances, So those are the kind of activities that has happened earlier, because of which we will be able to, say what will happen tomorrow. So if your machine, that is exactly what we designed machine for. The machine should be able to help us what is going to happen tomorrow. Yeah. A lot of, we can also start, maybe we can start looking at, if I earn like this, maybe after so many years, if I understand my spending behavior, I see hundreds of people spend in a similar way, whether that guy became a rich guy or a poor guy. So maybe based on that, we can also start doing something like that. A lot of analysis can be done, even in the stock market, for example. We'll be coming to more of that as such. So what happens is, when you go into the stock market, what happens is, a lot of people, there is an election, or there is some announcement taking place at the central government level. Then the market goes up and down. On the basis of this, you can actually predict what will happen when the market goes down. There are some people who buy stock because after a few days it'll come up. All this happens. So you can actually use machine learning to, understand and analyze the data of the stock, because stock data is generally available most of the time, because you get it on the newspaper, you have it almost everywhere, you'll get for free. And so it's almost not very difficult for us to analyze the data. So what we did actually is one of the very interesting data I can also share with you all if you want to practice. What we did was, we had the data of Titanic, all the passengers of Titanic, we had all of it. And then in that, we did some kind of a study on it, because we just wanted to see whether the machine learning algorithm that we worked with some of my researcher, whether it works or not. What we did was, we had the passenger manifest. That is, passenger manifest is the list of passengers. I have that with me. If you want, I can share it with Uma ma'am, and then maybe you can take it forward. for your trial purpose and for experimenting on your research work, what we did was, we have this bunk class, then first class, and all those different classes of tickets people have bought. Some got in from Southampton, and some got in from different places. And by the time they reach, some of them travel with their family members. Some were traveling with young children. Some were couples. Some were single travelers. So all kind of information was available in regard to a particular passenger. On the basis of this, we also have the list of passengers who survived. So what we did was, based on this two data, we wanted to predict if we have a particular, suppose if a person has booked this particular class of ticket, the chances of survival was higher. Okay, so we wanted to do that kind of prediction. So whoever sat in particular area close to the lifeboat or close in the bunk area, the lowest class of the category of the ticket, so those seated there, or maybe those who are traveling single, they survive better. All this kind of thing we do an analysis. So you can use this, to test the algorithms that you have designed, and finally predict this. And later on, when you buy tickets, you can use this and say, okay, next time I travel a cruise liner, I should buy this ticket, because in case a mishap happens, God forbid, touch wood, and nothing like that ever happens. But then in case like this, would you like to buy which kind of ticket? So it's about just trying to understand, the machine learning and predicting what should happen and what are the kind of things that we can actually do. Because normally we would like to go to a pundit, or what you call a panda, or what you call those fortune tellers. So probably we would like to change this fortune teller concept, right? I'm not against the thing, but if you look at the entire concept of fortune teller as per the sun sign, the zodiac sign, I think we have 12 zodiac signs, right? We have 12 zodiac signs, that is Aries, and what you call that, Pisces, and what you call Scorpio, and so many other signs you have. I think around 12 we have. So the population of the world is about I think about 8 billion. That's the total population of the world, I assume. So approximately. So if you divide this into the entire population of the Earth into 12, I think this is classification you are doing. So you put them into 8 different groups, then probably all around close about 60 crore or something is I think around 600 crores, somewhere close to that, is coming under each zodiac sign. Yeah. So the fortune teller predicts that this particular sign will get lots of money. That means there's 600 crore people will get money. So we all tend to get excited about it. I don't know whether it's correct or not. So we want to make this more accurate. That is what machine learning is actually trying to intervene. On a lighter note, I'm not saying this is bad or good or anything about it, but what I'm trying to say is the classification, when it becomes a large crowd inside, the prediction becomes inaccurate. That is all I'm trying to say. When we have the size of the class become larger and larger, then the chances of making mistakes are also higher. So the prediction chances are also higher. So that means 600 crore people will not get money in that particular week. Maybe a 10% will get, because the classification has become so huge, the subclasses has become so huge, then it becomes difficult. So probably in that case, you might also like to subdivide into smaller subgroups so that the prediction becomes much more accurate. That's all I'm trying to say. I'm not saying that this is right or this is wrong, but that you may consider that as one of the examples of using machine learning. Again, so when I talk about learning, as I was saying, though we're almost coming to a close of it, I just want to highlight the learning that we have been talking about. I said machine learning, and if you look at it carefully, all type of learnings in the world as of today are into two different types. Even in our ways of teaching to our students, it falls into these categories. Technically, right now we have the major three, the top three. That's why I've segregated the last one separately, because this is relatively new in the concept of computer science. So what we actually have been doing is supervised learning. So we help the computer takes up one data and say whether this is attendance data or whether this is temperature data. So the attendance will not cross 100, some kind of input you keep giving in. So that is called supervised learning. So we help the student. So in the early childhood days, the child tries to write A, B, C, D, and his or her hand, the motor controls are not so very good. So you hold their hand and then help them write A. Then after a period of time, you leave their hand and then they started writing on their own. That is called supervised learning. In case of unsupervised learning, the machine starts picking up things on its own, and then some more learning, additional learning that comes up. For example, when we were very, very small, when we were very small, we learned, our parents kept us telling, do not touch the fire, it'll burn you. We all said, parents all, we have been telling our children also, saying, don't touch the fire, it's very hot, it'll burn you. But is there anyone who has never got their hand burned? I don't think there's anyone, because till the time you touch yourself, you do not believe it. So you touch it and then you learned it. So that is what it is. So that is what is called an unsupervised learning. Over a period of time, next time when you try what things are there, you don't touch, because it has become unsupervised learning. You don't need to be supervised. Your parents told you once, you didn't believe it, you touched by yourself. Now you learned it. Now next time when there's a what thing, you don't touch it, because it has become a unsupervised learning. There's no more supervision. Parents are not telling you anymore, you don't touch them, because you know it is hot and it's going to burn your finger. So that is what it is mean by unsupervised learning. Then there is something called reinforcement learning. Reinforcement learning is very interesting, and I think this is quite an experimental kind of learning that we frequently do with our children. We say that you get this, do this homework, complete this. Don't watch your don't play video games for 2 days, and I'll buy you a pizza, and this I'll buy you a toy if you don't think so. What we do in case of reinforcement learning is we do reward and penalty mechanism. If you are successful in learning, we give you some reward. If you have a failure, if you miss it, then you are given some penalty. Say for example, a student does not complete his homework, we penalize them saying that you write 2 times. Okay, that's a penalty. But if he does the homework on time and submits it regularly, you buy him or her a chocolate and give and says that very good, you've done it well. You give an extra 1 mark. So these are kind of reinforcement learning. So reinforcement learning is again a very interesting way of learning. We can do this in case of your computer's machine learning. So when you design your computer or program to, the machine learning system, you can have this tree type of learning as well. And recently a new type of learning has come into existence. This has been there for a very long time. It's called federated learning, but it has been deployed in computer science, I think, more recently than the other 3. That's why I put at the bottom of it. So what we do is the learning, instead of having one computer trying to learn, or because when you have a large set of data trying to learn, it takes a huge number of days. So what we do is we use it on a federated computer. What do you mean by federated? Federated means distributed. Simple as that. So some data you are using on the computer, you are playing games, and then at the background of the game, the data is being trained by your computer or by your mobile phone, and then it is sent to the main computer. Okay. Likewise, multiple player, try to do, instead of learning 1,000 data, your mobile is learning 10 data. So what does it mean? So likewise, 100 players are learning that as you are playing the game, at the background, the computer, the CPU that is inside the processor inside your mobile, because the mobile processors are very, very, powerful these days. So they use it and then they send the data back to the main server. If you are part of the federated learning paradigm, So once you learn that, it becomes a lot faster. So this is called federated learning. So this is again another new interesting domain that has just recently come into advent, and people have started using it. I think Google and Amazon and a whole lot of them have actually started deploying. I can tell you one of the very interesting example of business intelligence and machine learning intelligence that I have seen a couple of business industries working. For example, today we buy a lot of things on Amazon. One of the most interesting business intelligence technique using machine learning is like, sometimes you see a particular T-shirt on your say for example on your on Amazon or Flipkart. You go into the website and you show a beautiful T-shirt. I want to buy it, but it costs 5,000 rupees. I don't know whether I want to buy this. Is too expensive for a T-shirt. 5,000 rupees. I don't know whether I want to buy or not. So I kept thinking about it, right? So I put into the cart. Okay. Morning I checked. I didn't like it. I put in, then afternoon again, I came back from work and I checked 5,000 rupees for T-shirt. Instead, I'll buy something for my children. So I didn't buy it. So I again looked at it. Again, I was thinking there will be some sales and I'll buy it. So again, I kept thinking in and out, and then finally I put it into the cart. And then maybe I'll say, maybe after I get my salary, or if I get my the return from the what you call fixed deposit I give, if it's about to come out next month. So once it comes, I'll buy. All kind of things, started thinking of all those things. So when you do that, what is happening at the background is this T-shirt is located in, say for example, in Chandigarh in northern India. You are located in Tamil Nadu. The warehouse, there's only 2-3 T-shirts, and this is located in warehouse in Delhi or in Chandigarh or in North India. Now, what will happen now is when you are doing this again and again, what will happen is, since you have the tendency to buy, if you put it into the cart, you have a tendency to buy. What will happen now is the program that is there will tell the logistic team in Amazon saying that, you know, there is this person in Tamil Nadu who has put the t-shirt in the cart, so I think you should start moving to this t-shirt to the closest warehouse in Chennai. So what happens is, even before you place the order, the t-shirt is already in Chennai's warehouse. Now finally you have got the money, you decided, chalo, theek hai, let me just do it. I will not buy any more clothes for the next 3-4 months, but let me just buy the t-shirt. I like it so much. You place the order in the morning, and afternoon, in the evening, before you return from office, as soon as you return from office, you find a t-shirt is in your house. You're like, oh, how did it come so fast? There was machine learning taking place, you know, a whole lot of activity taking at the background when you are doing this. So these are the activities that we can actually do in machine learning. That's all I just wanted to tell you as one of the examples of it. So moving forward, I'll just tell you some of the application, like say, for example, we can use in tourism, very, very interesting tourism, because I work with lots of startups right now. I have close to about 42 startups working with me in my incubator, because I run an incubator here. So the startup works on various things. So some of the interesting phenomenon that we have proposed earlier is like, you know, the tourism is like, you want to come to Sikkim. I'm located in Sikkim. So in Sikkim, it's a beautiful place. There's snowfall and a lot of beautiful place. You want to see, you want to pay money and come. But the problem is there's a lockdown. So before you come, you want to see how does it look like. So you will have your virtual tour of it. So you can sit there and see how it looks like. So, oh, you can plan, oh, this, I can avoid this place. I can go to this place. Oh, this place, I like it. You can see the entire Sikkim, and then in your itinerary, you can put which other places, because you cannot visit the entire Sikkim in one day. Yeah? So that is how you, suppose you have only 3 days to travel, which other places you want to go. So in a virtual tour, you take it first, then you do it. If you want to go to Singapore, you have this whole thing in the virtual tour first, then you put it into a package, and then you travel there. So a couple of my startups are working on this. They're able to sell a couple of things, many of them, you know, having a virtual tour before they actually come and visit here. The next is, you know, surgery. We have seen about an X-ray vision by mapping the CT scan image, and the patient's body is mapped by using some kind of a camera, and then you get an X-ray vision, so that, you know, you have a very high precision surgery possible. So in military, we also have a startup deployed last year. You can see the number plate of a vehicle as far as about 10 kilometers away. So yes, Uma, is it time?
Yes, the audible. So participants, kindly mute your mic. Yes, go ahead.
Okay. I thought my time is up. So okay. So we do the packaging industries, production line, logistics, financial forecast, which I've told you earlier. So I'll show you a brief video of 2 minutes. I think I have about 8 minutes, 9 minutes. I'll just briefly take you to a tour of 2 videos about 2 minutes each, and you will have a better understanding of it. I'll just show you here. Sorry? Is this video visible? Professor Uma, is it visible?
It's visible, but we can't able to hear the audio.
Audio is not clear?
Audio not clear.
Okay, I'll just try again.
Okay.
Is it coming?
The audio not coming.
Okay, audio is also not coming?
Yeah.
Okay, I'll try to.
Just you change the settings in Google Meet.
Okay, I'll just check once.
Video okay. Audio, you change the audio settings only.
audio is
Microphone.
built-in microphone.
Yeah.
Okay. What I will do is I'll do the airport. Okay. Now I think it should be okay. What I will do. Is it audible now?
No. Yeah.
Okay, I'll just.
Yeah, it's audible.
Well, this is one of the videos, and I would like to show you a second one, which is also equally imperative, which is also equally important. I would like you to see the other applications of machine learning in other application area as well. So here we go. Well, that's all about it. So thank you so very much. If there's any questions, the house is open for questions. If there's anything, so I think we have another 2 to 3 minutes. You can just, if there's any question,
Can I ask one question?
Please.
I'm Dr. Atul Bhargav from Jaipur. And incidentally, I'm an alumni of Sikkim Manipal also.
Wonderful.
Sir, you have worked, I think you have worked a lot on COVID research.
Okay,
what I have understood through your communication. So my question is related to your machine learning, which said classification, clustering, and regression. If we see the Indian data recently, means in last 45 days, they say around 4 lakhs patients are positive. And we assume that for every patient, there is a chain of 50. Means he must have come in contact with the 50 people at least. Isn't it, sir? And if we see the total calculation in 45 days, it comes to 90 crores. And surprisingly, 40% of population is children below 18. That is around 58 crores. So somewhere there is a locha in the data. That one thing. Second thing, they talk about herd immunity. I think above 50%, it is, or above 60%, it is herd immunity. Isn't it, sir?
Okay, tell me, complete your question.
Yeah. What I'm saying, on the top, they're talking about the third wave. If we have touched almost 90 crores, which has developed natural immunity. Second, the what do you call, the vaccination is done on around say 16 crores. Population which is not affected is 58 crore. What kind of data they are providing, sir? I think we are not coming out with the correct data. And on the contrary, there is no follow-up of the adverse vaccine reaction, because there is no follow-up of the patient. They are providing that data also. They are coming out with that data also, which is for adverse vaccine reaction. So I think when they are saying that the mortality rate with vaccine is 0.06 in India and in UK it is 4%, I have my own doubts that the data is not correct itself, because there is no follow-up mechanism in our system. And the numbers which are showing, they are exaggerated, or even they are miscalculated. So if I see the machine learning part, I think one can easily understand that the data which is coming out in the press or the government which is providing, that is not absolutely correct. And there is, if it is true, then there is no third wave.
Very nice question, Dr. Bhargav. Very nice intervention. I'm just sharing what I showed today in the morning. I think you can see this particular, So this is what I show, and I have nothing to do with the data. First of all, let me just clarify. I'm just another researcher like you. What we do is we do our own research based on the data that's available. Unfortunately, if you get your hands on the wrong data, probably your outcome and predictions are not going to be correct. We as researchers try to develop a system assuming that the data is available, the data that is given to you and to me is correct. Assuming that is correct, we are interested in designing a software or a program or a platform which is going to predict what will happen next. Like how you said, I will not be in a position to explain as to whether the data is correct or wrong or good. It'll be wrong on my part because I have technically not worked on those data.
What you have mentioned in machine learning, I'm just using that and coming out with a conclusion. Nothing, and the data is what data they have shared. That is it's available everywhere.
True. Okay. So there is one important aspect of this component which I could not cover today. I just wanted to quickly highlight. Actually, there is something called an outlier, which we have always not related to the vaccine or to the other thing where you say that there's an overlap of the numbers. So what actually happens in many cases is there is an outlier overlapping or a thing or a data which is really not relevant, but we happen to take it in. Say for example, whenever we do cancer study, I'll just give an example. Whenever we do cancer study, what we do is there are some people who have recovered. I hope you'll agree with me, Atul sir.
Yeah.
So what happens is in most of the studies that we have done, I'm sure if you have studied also, if you have taken this data also, you have always studied about the number of cancer detection. How did you detect it? How do you see and how do you detect it based on this particular? But have we ever taken the data which has recovered? Because they are very few in numbers. We have always ignored those data. So the data that has ignored has generally created the outcome that we do may not be as accurate as possible. So this data, which is not considered, but which are very, very important, generally falls under the outliers. Probably, I'm just assuming. I have not taken this data, so I'm just assuming. So some of those data where you say there is a coincidence, where you wanted to have the correct data doesn't seem to be, it seems to be an overlap of the population size and the kind of things that is available. So what I feel is, it could be that this data falls under the the outlier, and probably that is why we did not consider it. That could be one of the reasons, but we'll have to see this a little more. So,
sir, when the outlier percentage is so high,
I know
I read about outliers, but it's the data. If the percentage is so high, that means even
yes,
that
means something is. I'm not saying that it falls into the outliers. All I'm trying to say is the outliers could be one of the important considerations which we have ignored. That could be one of the possibilities.
I agree to that. I agree to that. Even if it is 10%, I agree to that, sir. But the funny thing is that now what we are going to study, what we have done in whatever the research has done in UK or USA, we are going to implement here.
Okay.
But believe me, both the data has to be different, because our T cell immunity is different as compared to Western countries or European countries. That is why in the first wave we are not much affected. So whatever they are going to follow now by using the international data, that is not going to give us the desired results which we can apply on Indian population.
Then, sir, all I can say from my perspective is, assuming the data given available to us, to the research community is correct, all I can say is, we have to design a robust system. That's all about it. But when the data itself is like, we'll have to see what source we are getting the data. I think based on that, we'll have to look at it, because I'll not be in a position to comment which data.
Sir, I was just why I highlighted this thing. I think there should be a feedback mechanism. Unless until there is a feedback mechanism, the cycle is not complete. That is what I was saying. And there is nothing wrong with the efforts which we are putting, but there has to be accountability, and there has to be a feedback mechanism which should be incorporated, because you people are already into this research already. That's why. That's it.
Okay. Thank you. We will try to see. I think
it's a big discussion otherwise.
Right. Anyway, I think this is a different topic altogether. This pertains to policy, I think, more than the research. Yeah. Anyway, thank you so much for the input.
Thank you, sir.
Thank you. Yeah. Any other questions?
So, participants, if you have any questions, so kindly ask now.
Yeah, may I?
Please, Avinash sir, please.
Sir, machine learning are used for the automation. So in augmented and virtual reality, how it can be used?
Okay. I wanted to bring this concept of machine learning into the various application areas that is possible, and it's not as if machine learning cannot be deployed in augmented reality or virtual reality. When we talk about, I've shown you a couple of videos now in computer vision. When we talk about augmented reality or virtual reality, we are also processing the images, multiple layers of images where we are trying to process. In that case, what happens is which ones should be adopted, which ones should not be adopted, so that the most accurate vision that you would like to have can be classified. So when you're dealing, say for example, you have taken multiple layers of photographs, and then you have thousands of images. But if you have to manually do this, probably it'll be a very difficult task for you to actually process it and convert it into a virtual reality or an augmented reality. Under such circumstances, probably if you use machine learning, or maybe for that matter, neural networks and deep learning, some of the new age technology, this will probably improvise on predicting which one will be the best option for you. That is all we wanted to highlight here.
Okay, that means you want to say for an analysis purpose you can use.
Yes, for the analysis.
Okay.
Correct, exactly. Yes.
Okay. Okay, thank you, sir.
Yeah, thank you.
So, any other questions?
Sir, can we use AR and VR in geospatial data analytics?
Geospatial, sir, to be very honest, I have not worked on this, but I'll have to see, because I have not worked on geospatial, but I'm sure there is a provision for this. I'm not expert in that subject, but I think there are ways which can be deployed. I'm sure there would be ways, sir.
Okay, sir. Thank you.
Ma'am? Circulation, ma'am?
Yes.
Okay, ma'am. Kindly give vote of
Yes,
thanks.
ma'am. Yeah. Thank you, ma'am. Thank you, ma'am. It's a time for vote of thank. On behalf of Nanamani College of Technology, Department of CS in August, I thank our resource person, Dr. Tej, for providing gracious presence today to enhance our knowledge. It was a great and informative session. We wish to express our gratitude to our honorable resource person for being with us on this event. Thank you so much, sir. Better than 1,000 days of diligent study is one day with a great teacher. Thank you so much for this great learning. I extended my thanks to each and every participant for kind cooperation. Thank you all.
Thank you, ma'am.
Thank you, ma'am. Thank you so much.
Thank you, everyone. Bye-bye.
Thank you.
Ma'am,
Thank you, Professor.
Thank you, sir.
Okay, dear participants, the next session will start at 2 o'clock. So the feedback form is in chat box. Kindly fill the feedback form. Thank you.
Ma'am, we cannot fill
Okay,
it. Hello,
thank
ma'am.
you.
Yes,
Hello?
yes.
Ma'am,
Yes,
it is
ma'am.
asking for access right. I cannot fill up the feedback, ma'am.
Which session,
Requesting
ma'am?
for access.
Which session, ma'am?
This one, current session, ma'am.
Current session, it is the chat box, ma'am. Kindly fill.
Ma'am,
Fill
it is
it.
there in chat box, but I try to connect. It is saying that request access.
I can't get you.
It is asking for request to access it.
No, ma'am, it's working, ma'am. All are filling.
Roshini, ma'am.
Yeah, ma'am.
I
Tell me,
think
ma'am.
you have opened the jam file previously posted. Kindly just try to open the last one.
Okay, fine.
Hello, ma'am.
Okay, okay.
Hello.
So now the feedback
I'll
link
try
is
to
in
open
chat
it.
box, ma'am. You kindly open the last file, ma'am.
Hello.
Okay, fine. Got
Hello,
it,
ma'am.
got it, ma'am.
Yes, ma'am. Yes, ma'am.
Can you share
Got it,
session
ma'am.
4 feedback link? Because there was an electricity problem at the end. That's why I could not fill.
So you kindly send the message separately, ma'am. So I will note your attendance.
Okay, ma'am.
Okay, ma'am. Thank you.
On a mail, should I send?
My number. So it is in WhatsApp group.
Okay.
Okay, ma'am.